So today's class will be mostly about R, introduction to the basics of R. That will definitely help you guys in the future, but also will help you to complete the assignments from now on.
Professor, I have a question.
Sure.
Should we expect to do R or use R when we're taking the next midterm or the final?
No, but I mean, sometimes we find it really helpful. For example, if you will see that you will get used to R, for example, and you will probably see that some problems are much easier to solve in R
Okay,
because
thank you.
there you have like a few clicks and you get the answers. But I've never required students to work in R to complete the exams, but you may find it useful.
That makes sense. Are we still on chapter 4 or have we moved on to chapter 5?
We almost finished chapter 4, but I will kind of review certain stuff I want to just emphasize before I move to explaining certain basic stuff in R. And
Okay,
also I will show you guys how to do stuff in Excel too. So, but the thing is, I asked you all to download or and install R on your computers, and the instructions were on the CUNY Blackboard. Even though I will do stuff here in my computer, it will be useful for you guys if you do that simultaneously so that you learn, but definitely it will be also, I think, I mean, it can be helpful. You can also do it like after I post the recording on the CUNY Blackboard. So let me remind you guys certain parts from this chapter 4. So we have this chapter was about a linear model with one independent variable, right? So with one regressor, and the model had this form: yi equals beta 0 plus beta 1 times xi plus ui, right? And we know that this is a population, we called it a relationship, right? Population relationship, right? And we know this is a disturbance term, or in other words, an error term. Or in other words, this is also known as error term, which we don't know. And we also don't know beta 0 and beta 1. But we want to get an idea, right? So we still want to know what are the best possible estimates of beta 0 and beta 1, right? So we can obtain the estimates of beta 0 and beta 1 by using ordinary least squares method. So OLS, right? By OLS, you can find beta 0 hat or beta 1 hat, right? The details are in the previous class recordings or class slides. How do we get it? We get it by minimizing the sum of squared residuals, right? From 1 to n is your sample size, but you are minimizing this with respect to beta 0 hat and beta 1 hat, right? But where do we see betas? Here we don't, but we know that U hat is a difference between the actual y and the fitted y hat. That's the fitted y, right? And again, I changes from 1 to n. N is your sample size. Still, we don't see betas here, but beta heads here, but we know that y I head is what? Can you tell me? That's the y head I. And you are minimizing this entire sum with respect to beta head 0, beta 1 head. When you do this optimization, you will obtain that beta head 1 is covariance between y and x divided by variance of x. And the beta head 0, that's just y bar minus beta head 1 times x bar. Guys, do you have any questions? Because I'm not seeing your texts and it looks like you're texting. So, but okay, so these are the estimates. You have the data, right? So we have the data. So this is n 1, 2, 3, and so on. Whatever your sample size, let's say 500. And then you have values for x and values for y. So here you have these values, right? So then you can calculate x bar, y bar, covariance between y and x, variance between y and x. So you can calculate beta head 1 and beta head 0. Guys, am I clear?
Yes.
Yes.
Okay. But then, okay, so then you get the estimates, right? So when you calculate this covariance between y and x, variance of x, and then you plug these numbers, and then you get the number. So the number for beta head 1, then some number for beta head 0. So those will be estimates. But before you plug those numbers in, what do we call beta head 0 and beta head 1? Those are estimators, sorry, estimators for beta 0 and beta 1, right? And you want to make sure that they are good estimators. How do we know that? It has been shown by others. But how did they show that? They showed that beta head 0 and beta head 1 are unbiased, consistent, and efficient estimators for beta 0 and beta 1. Thus, beta 0 head and beta 1 head are good estimators. Now we have to, maybe we want to test the hypothesis, and we do want to test the hypothesis about beta 0 and beta 1. How will we achieve this? Can you guys tell me? what do we need to say test a hypothesis about beta 1? What do we need to test a hypothesis about beta 1? We need a sample analog of that, right? So what is the sample analog of beta 1?
Beta 1 hat.
Are you here? Beta 1 hat, yes. So we will use beta 1 hat to test the hypothesis about beta 1. Okay. So let's say I want to test this hypothesis that H now beta 1 equals beta 1 at 0. That stands some value, right? At the null hypothesis. It can be anything. The alternative is beta 1 is not beta 1 at 0, right? Usually people take this to be 0 because that is very useful. Why? Because that helps whether the variable, whether your independent variable matters for explaining your dependent variable or not. But then we will talk about that later. Let's simplify. Let's assume, okay, assume beta 1 0 is really 0. So then we are testing the hypothesis that H now beta 1 is 0. The alternative is H alternative is beta 1 is not 0, right? And to test the hypothesis, you need to construct a test statistic, right? Which will be what? Beta 1 hat minus the hypothesized value, which is 0. That's the hypothesized value. And divide by standard deviation of beta 1. The problem is that we do not know standard deviation of beta 1. So what do we do then?
Get a sample?
We already have a sample, and then just calculate standard deviation of beta 1 from your sample. We denote it by sigma hat of beta 1, or we also denote it by S of beta 1, because it's like sample. S is an abbreviation of sample.
Do you have to normalize it?
Sorry?
Do you have to normalize it, or you have to get standard deviation over n, over radical n?
I understand it. No, I will give you formula for this. In a minute. It's not y bar, whoever you are. It's not y bar. So it's not y bar. So because S sigma of y bar, you are completely right that it's sigma of y divided by square root of n. You are right, but it's not y bar. It's beta 1. And S of beta 1, which is the sample standard deviation of beta 1, it has a little more involved expression than just sigma of y bar. Am I clear?
Yep.
And I will show you the expression for this later, like in a minute. But I wanted just to emphasize that you never know sigma of beta 1, that's the true standard deviation of beta 1. You never know this. So instead, you have to calculate standard deviation of beta 1 from your sample. Okay, guys? And it has an expression that I will show you later. Okay, can you tell me what is the distribution of T, this test statistic? Because eventually you will be comparing test statistic to what? The critical value that you will take from whatever, from some distribution, right? So you need to know what's the distribution of test statistic. Can you tell me what is the distribution of this test statistic? Guys, I really want you to be involved in class. Don't be ashamed of asking questions. I will be very happy to answer. So okay. Depends on what is the distribution of beta 1 hit, right? The distribution of test statistic clearly depends on the distribution of beta 1 hit, right? Also, you have sigma of beta 1 here. Now, let me tell you this. First of all, the distribution of the test statistic is not normal. Because we use, so guys, this is really key, so please follow. Because we use the estimated standard deviation which we denoted by what? S of beta 1, right? Instead of the true standard deviation of beta 1. So which we denoted by sigma of beta 1. So because of that, the distribution of test statistic is not normal. But then instead, test statistic follows student T distribution. This is shown. We don't show this in class, but that is shown. So here we just emphasize that the distribution of this test statistic follows is student T. So test statistic is taken from a student T distribution that is given in table 2. So we will have examples, we will have exercises, don't worry about this now. Now let us see, so because as you already saw, we need sigma of beta 1, we don't have that, so we need S of beta 1 to calculate the test statistic, right? So we need to know what's the variance of these beta 1 hit. So we need to know that. It should be hit. Here should be hit. So now let me show the expressions for the variances. So guys, this is in your class slides. I'm not asking you to memorize it. Oh, you don't, do you see it? You don't, right? So I have to share the screen. How do I do it? So do you guys now see my PDF file?
Yes.
So see, let me increase in the size. So now I just want to, so this is sigma squared of beta hat 1, which is calculated according to this expression. And this is sigma of sigma squared of beta hat 0. You don't see hat here, but it has half hat. You will see in the textbook that. So you have these complicated expressions. It's not just sigma of y divided by square root of n. I just want to emphasize that. It's quite complicated expressions. These expressions get even more complicated when your error term is heteroscedastic. I will talk about that later because we don't talk about heteroscedasticity is not today's topic. I will talk about heteroscedasticity and homoscedasticity next week. Now let me show you guys how we do this in Excel first. How we run a regression in Excel, and then I will show you guys certain examples in R. So now what I want you guys to do is, do I have this uploaded on the Kine Blackboard? Let me see. So I want you guys to go in class 7 folder on the Kine Blackboard, and there I will upload in a moment certain data sets, and I want you to download them. So guys, if you can go to our course, then go to go to Vic 7 folder and download the datasets I just uploaded. And then open the first one, California School dataset. When you download, you will be seeing a lot of numbers there, but I want you to pick a few columns of interest. So do you see my Excel document?
Yes.
Okay.
Yeah.
Have you opened it yourselves? So what I want you to do is first, you need to install certain add-ins to your Excel if you have not already done it. So go to File. When you open Excel, go to File, then go to Options, then go to Add-ins. Then you will see on the bottom, you will see Excel add-ins. Click there, and then you should check the first two. We need that for the to be able to run certain regressions in Excel. So select the first two, analysis toolpath and analysis toolpath VBA. That's not really necessary, but then you click OK. Guys, did you do it?
Yes.
No, could you go over that?
Sure. So File, then go to Options, then go to Add-ins, then at the bottom you will see Excel add-ins. Then click Go, and then select the first two, and then click OK. Did you guys do it?
Yeah.
So next, what I want you to do is the following. Select, okay. Okay, go to Data, and you should be seeing at the right uppermost part of your screen, you should be seeing Data Analysis. Because we added this to our Excel. So, do you guys see it?
Yes.
Yeah.
Good. Now click on that, and then you will see a new window pops up. And then here we have a number of stuff. You can calculate correlation, covariance, and stuff. But just try to see this regression, and just select it. And then click OK. And the new window pops up. Guys, are you with me?
Yes. Yes.
And then it says input y range. Y is our dependent variable. Let's say our dependent variable is test score. So I start from this. Do you see? I start from this. This is the variable, but you have to select just you have to stop, because we have 420 observations in this, and you don't have to select the entire column. Instead, you need to select just the column, just the cells with the numbers and the title. So I will select, I already selected, so it is here. And then it says, when you click here, input X range. X is our independent variable. Let's say STR. STR is the student teacher ratio. So let's select it. So I select it, and it is already there. Then you guys see labels, right? Labels is select this because select labels because when I selected the columns, I included the labels too. If you guys noticed, I included test score and I included STR. I included labels too, so that's why I have to select labels here. So did you guys do what I did?
Yes.
Okay, if you did, then click OK. And a new Excel worksheet pops up. Did you guys obtain the same results as I did?
Yes.
So the last two columns, just delete it, it's nothing. And then I will just work on this. I will just, where is it?
Professor, where do we find the data?
I downloaded it from the CUNY Blackboard. I said to go to week 7 folder,
All right,
and then,
thank you.
and then, yeah.
It's
and
the
then,
CAS school one.
Yes, yes.
And then on the bottom, you gotta, there's different tabs.
So what do we see here, guys? What are these? These are the coefficients, right? Intercept is the intercept, right? STR is the independent variable, right? And we have a few other numbers here. So this here is our beta 1 hit, okay? And this number here is beta 0 hit, okay? What is this? Can you tell me? That's the estimated standard deviation of beta 1 hit. That is the estimated standard deviation of beta 0 hit. What is this? T-stat. How is this calculated? Can you tell me? That is a ratio of this number over this number. Why? Because, okay, let me talk about this when we have a class about hypothesis testing, and I will be clear about all of this, but this number is a ratio of that number over this. And here you have p-values for the test, and here we have the confidence interval. So these two numbers tell you that 95 confidence interval for beta 1 is whatever you see. Right? You also see R squared, you also see adjusted R squared. But the problem is that none of these numbers, and all of these numbers are incorrect. Whatever you see in red, those numbers are incorrect because Excel does not correct for heteroscedasticity, which I have not explained, but I will explain during the next class when we talk about hypothesis test. It is in chapter 7, not 7, it is in chapter 5. None of those red numbers are correct. But this is how what I wanted you to show is that this is how you run regression and obtain results in Excel. Now let me do the same thing in R. Okay. So let me ask you guys, how are we doing? Are you guys following me, or do I have to slow down?
We're following, but if you could go a little slower so we can follow better.
Okay, that's absolutely fine. But did you understand what I did before?
Yeah.
Now I want you guys, okay, let me ask you, because I don't know if you downloaded R on your computer, so friends, I installed R on your computer. So let me first ask you, did you download R and install that in your computers?
Yes.
Yes.
So all of you are ready for starting using R. So then let me share my screen once again. We will do certain examples in R. But what I already showed you guys is how you run regression in Excel. Okay. So what you see now is R. You see that I have opened R. So you need it to install R and RStudio on your computers. RStudio is very useful because just it is easier to do certain to do the analysis in RStudio because it is much more, how to say, much more how to say it, you are using R, but RStudio makes it like look better. So as you see, so you see this letter R, which is.
We should open R right now, right?
You should open RStudio.
RStudio, okay.
Yes, because yes, and when you open RStudio, you will have a different kind of. You may feel that you have.
Because you customized it, right?
I customized the color, so.
Good taste.
Really, thank you. So how can you change this background? You go to Tools. And then you can go to Global Options, and then you go to Appearance, and then you have lots of different. So here you have these lots of different themes. Okay, guys, and you can pick whatever you like.
Green, I don't know why.
Oh, then see.
Does this use Python? What is this code?
This code is, this is R. Everything here, what you see is coded in R.
Similar functions.
Similar functions, yes. So all these Python, R, MATLAB, those are very, very similar, just very simple, very, very slightly different coding styles.
Professor, so I opened RStudio and it says, the JIT command requires the command line developer tools. Would you like to install the tools now? Should I click install? It's asking developer tools, even though I installed RStudio already.
Probably no, you can just X and that's it.
Okay.
I think it should still work. So guys, you now know how to choose different themes, right? Do you see my screen? I'm just showing you how to choose different themes. This is just my choice, so whatever I have here. So then I have some codes. Of course, you are not expected to go over all these codes, but let's start, right? And we will be doing this over the semester. If I have time, I will introduce you guys with Python too, but Python, you will have to download it. The good thing is that both Python and R both are open source and free.
Professor, can I ask a question?
Sorry, could you repeat?
Yeah, I just wanted to ask a question. So I did open RStudio, but I don't have these tabs. Like you see how you have view, plot, session, build, debug.
Yes.
That I don't have that line.
You should close it and open again.
I did, and I don't have it again. I have everything else, but not these.
Okay.
Are you sure you're on RStudio?
Yeah, I'm on RStudio.
you use a Mac?
Yeah, I'm doing on Mac.
It's on the top. You have to like pull up and then it come down from the active.
Was it helpful?
No.
I don't think I can be more helpful because I don't know. So what I recommend is that maybe you need to install again. I don't know.
Okay. Okay, I will try.
Yes. So guys, we will be working on this like over and over in this during this semester. So we don't have to learn everything right away. We will learn this step by step. But let's start, right? So to be able to do stuff in R, you need to first install certain libraries and then open that libraries, right? So do you see what I mean? So there are certain libraries that is already like built by others. The library means that the functions that others already worked out. So then you just open that library and then use whatever others did before to run your models and regressions and obtain results. But clearly you first need to install whatever library you need in your R and then open that library and then proceed from there. Guys, what I want you to do first is, okay, so 8.6 class, so this is from before, but I will upload that right now on the CUNY Blackboard. 8.6, I will copy this and then I will just change the name of it. It will be
Professor, your screen's black.
really? Okay, that's fine. I will make sure that it's not. I'm not sure why it's black. I am now just uploading some R code on the CUNY Blackboard. So guys, I uploaded, not yet, but I will. Go to week 7 folder, guys, once again. And then you will see 10.9 class R. Okay. And download it. Let me know.
Sorry, is it week 7?
Yeah, it is week 7. I have just uploaded, and please download 10.9 class R.
Yeah, it took a few seconds to show up, but it's here.
Oh, good. So, and download and open it in RStudio, guys. And please let me know once you have done it. When you open, Excel. Okay. Okay, if you guys open, you should. Do you see my blue screen?
Yeah.
So when you open, you will see all of these comments. So there are a lot of comments, but you don't really need to, guys. This is like you are not required to know all of this right now. We will just go step by step. But do you see the same comments that I have here once you open R?
Yeah.
Sorry, for me it only allowed me to open with RStudio.
Yes, the same thing. I'm doing the same thing. When you open RStudio, it means that you opened R using RStudio.
Oh, okay.
So on line number 7, there is this comment. Do you guys see? Do you have it? Do you have the same comment on line number 7?
Yes.
Professor, I wasn't able to open the file.
First, you need to open RStudio.
It's open.
And then go to File. Go to Open File. And then then you need to see the location of your file. But my file is in Dropbox. And then, so my file is in week 7 folder. So I click on week 7 and then I just find wherever, this is the file, and then I click open. You should do the same thing. This is not the file, but this is, right? You should, when you click on that, when you click maybe twice here, or maybe when you click open, then you should work.
It worked. Thank you.
So on line number 7, you have this, right?
Yeah.
This means that you clean whatever you have. You clean your the windows, this like sub windows. This is, for example, called console. Right here, you see all the data sets that you have. For example, you see certain stuff. You will not have this, right?
Yeah,
No.
correct. We don't have it.
You don't have it because I've been doing certain stuff, so that's why I have it. That was left from before. Okay, guys, am I clear?
So that's like different files.
Yeah. So I was working in R, so then I did not close those. So they then R looks like R saved that in them. When I am working on a new data set, or when I am writing a new code, then I don't really want any of this to be here. Okay, and I want to clean it. So the command for that is this on line number 7. You select it. How do you select it? You just click on this. You then run. You see run, guys?
Yes, we see run.
And then it cleans. If you click it, you see that the environment is now empty. Okay. Now let me ask you guys to install this package, Stargazer. This is a package this is a good package because that helps us to have more beautiful figures and stuff like that. Okay. And when you click on that, in the console, you will see that R is working on it. And eventually it should say that it was successfully unpacked or something similar. Tell me, guys, if you managed to do it.
Yep.
Wait, how did you download it? You click on line 11.
Just click run.
Yeah, just click on
Highlight
that.
it. Highlight.
Professor, for
Yes?
some reason it says here, warning, R tools is required to build R package, but is not currently installed. Please download and install the
appropriate version of R tools before proceeding.
Yeah.
That's fine, guys. Sometimes you get the kind of weird things, but as long as it says successfully unplugged,
Okay, yeah.
then it's okay, right?
Oh, and also, Professor, under
So
the console,
first let me say, warning is not an error, right? Warning, you may get warning, that's fine. Still you read it and see what's going on. But if you have error, which I believe will be in red, then you have a problem. Then you cannot proceed and you have to take care of it. Now, please ask your question.
under console, I do not have terminal or jobs tabs on the bottom for some reason.
I don't have the answer. I don't have an answer to that, but I have never used it. So
okay.
I don't. So that's. So I don't know.
Okay, so you never used it. Okay, so I'm fine.
No,
okay.
no. I think it probably don't need it.
Okay, all right. Thank you.
No problem. Now please guys open these libraries. Just highlight those and open, just click run. And it says loading, 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 and then, it does it. So line 18 is a repeated line, so please disregard it. Now let's work on this. So guys, do you see these CA schools, California schools? I highlighted, but I'm not sure if you see.
Yes.
Okay, that is in this package, in this library, AER. So since you opened this library, it means that you opened everything that is in that library. And this data set is in that library. So now what I am saying is just give me this data set. And it does. Okay. When you click on 20, line number 20, when you select this line, you are telling R, give me data with the name of the data set is CA schools, and give me that data set. R will be able to do that because you already opened library AER specifically, which does have this data set. Am I clear?
Professor, I'm getting errors.
Me too.
Error in the library, open parentheses, AER, close parentheses. There's no package called AER.
For me, it says warning message in data AC schools, data set AC schools not found.
Guys, you are fine. You are okay. So you are correct. So first we need to install package AER. So let's do it. So install, so below, please do this. Can you write it?
Yeah.
That's because we don't have that. I had it installed before in some other code, but looks like in this code I don't. So
is this off GitHub? Where is it being downloaded from?
This is so these packages are built in R, guys.
Do we also need to download mass?
Yes, but not now. Mass is for testing hypothesis.
Oh, it's downloading a lot of things.
That's okay.
Then he hacks our computers and has all of our information.
We
have to type in install package AER, right? In line 13? Okay.
Yes. Guys, I think we are already hacked. I'm joking, but so,
are you?
I don't know. I'm just kidding, but I know I'm not.
Professor, I'm seeing a lot of downloads.
Yeah, I mean that's okay, guys, because
it still says that the data set can't be found for the test schools.
I'm still in the phase of downloading.
Guys, it takes a few moments.
They're getting into my mainframe, Professor. Oh, it's done.
Okay.
Never mind.
It takes a few moments, guys.
Professor, it says warning. Your information has now been sent out to C::, hacker RS. I'm joking.
What?
I was joking.
Okay. But if you have something like that, then we have a trouble. But
it's the KGB.
Guys,
they're coming for us.
Yeah. So guys, these packages are not really. So these packages are serious packages. It's not like, I mean, those are not hacks or anything like that. Okay. So don't be afraid of this kind of thing. But I mean, you need to know what are you installing in your computer. That's definitely true. But these are not packages that will hack your computers.
So it's only AER that we need to install.
Right now, yes. But then we
Okay.
will need to install bus and others, but not now.
Should we run all three libraries again or just AER?
Right now, we just need AER.
Okay, cool.
I know all of them, but we need AER right now. Now, guys, you will be able to open data CA schools. Let me know if you are able.
Sorry, if after installing AER, do we also need to run?
Open. Then you need to open the library, right? So library AER.
Okay, so we just run that and then the data schools.
And then data schools.
Okay, thank you.
So do you see this in the global environment? Do you see the data set?
Yeah, I see it.
What about others, guys?
Yeah. May you repeat what are we supposed to do?
So first, you install package AER, then open library AER, then open data, which is in that library, by clicking on data CA schools.
For me, it doesn't. This our package cannot be loaded. It downloads it installs the package, but the library doesn't run. When I run the library 120.
So did you install package AER?
Yes, I did.
So good. If you did it, and then you need to open library AER, and then you need to run this command, data, and then in parentheses CA schools. And when you do that, you should be seeing data set in that global environment.
I don't see it. Oh, I tried to.
Guys, was anybody able to do it?
Yeah, I see it.
I see it.
I don't. So we
Yes,
just
I see it.
select and click run. To me, it still says that it's empty on the side.
But you did do this, right? So you install, did you run this command?
Wait, what kind of message are we supposed to get once we do this? Like package?
You just should be seeing that data set in the global environment.
When you finally run library AER after you download everything, it should say loading required package, car data, stuff like that.
Let me do it, guys, again. So then that means so it installed. So if you install AER, it should say successfully unpacked. And then you open this library AER. There's a few moments, and then still working, okay. And then you click on, in my case, it's line number 22, but the command is data, and then in parentheses CA schools, and I run it, and then it should just say in the console, data CA schools, with no errors or wordings, and then you should be seeing the data set in the global environment.
Professor, I have a question.
Yes.
So every time we run this R program, this particular one, do we have to install the packages again?
No, but I mean, I did it for you guys once again.
No, I'm just curious, just for future reference.
No, you don't have to. No, it's
so then when you just, it won't like re-download and clutter your computer.
No, it will remember. If you just,
okay.
If you do it again, it does it again, and it takes a few more moments. It's not like it takes a lot of minutes. Just a few moments.
I'm just more worried about the space.
I understand. No, you don't have to. Guys, so how are we doing? Are you? Did you manage to open the data?
Somehow I just clicked. I clicked my way to having that.
But you are now.
Yeah, I have the data saying 420
Observation.
observation of 14 variables. Yes.
Yes, exactly. So you see it. What about others?
Yep.
Good, great. So guys, then do you see this white? It's actually like an Excel spreadsheet, but this is very small icon. Do you see it?
Yes.
Yes.
Click on it. And then you will see a lot of numbers, data on the here in one of your windows.
Can you show just once again, where did you click?
Sure.
That white white rectangular box.
Yes, exactly. Click on that, and then you will see. So these guys, whatever you see here is exactly, it's very similar to what we have here. The same data set. Okay.
It's a black screen.
I see. But do you remember we did certain stuff in we ran regression in Excel. So we needed, so we had this data set, right? What you have in R is the same data set. Now guys, go back to 10.9 class R. And let's say now, okay, first of all, what do we have here? We have different variables, grades, students, teachers, and others, lunch, computer. And we have read, math, English, income, expenditure, computer. What I want you guys to do is that we need to define certain variables. So how do I do that? Like this. Look at this line. So let's analyze this line. So I am defining size, or this is class size, as a ratio of students over teachers.
Oh, Professor, what does the dollar sign mean?
Now let me tell you what it means. So first of all, CA schools. CA schools is the name of the dataset. Am I clear?
Mm.
When I put dollar sign, I am telling R, look for or take the variable students from CA schools dataset. That's what dollar sign means. This means divide it by the variable teachers which you find in the dataset CA schools. That's what dollar sign means. Divide students from CA schools on teachers from CA schools. And name it size and put it in the CA schools. That's what this command tells you guys. Am I clear?
It's cap sensitive, right?
What?
Is it cap sensitive, the students and the teachers?
Because students, if you see, let's go to the data, you will see that students, teachers, those are in lowercase letters. Okay, students is a variable in your in the data set. Teachers is another variable in the data set. Those are not capitalized.
So, Professor.
Yes.
It puts the result of the quotient inside size, the category size.
It will create a new variable size.
Oh, okay.
In the same data set, because I am telling that create a new variable size and put it in the data set CA schools.
Mm-hmm. Okay, thank you.
Okay, now let me do it. Run. And then I will, when I go back to the data set, it will create another column in the last table. The last column will be this size.
Oh, okay.
Now let's do the same for because okay, we want to generate variable test score, and here we define it as reading score and the sum of reading score and math score. Divide by 2. So the variable score is defined as an average in reading score and math score. Am I clear?
Yes.
Yeah.
So I am saying this. Define a new variable score, put it in CA schools dataset. This sign means define. It is like the same as equal. And take the variable read from CA schools, add to that the variable math, which is in the CA school, and the sum in the parentheses, divide by 2. That will be a new, I'm telling that's the new variable score. When I select and run it, I will see that in the dataset I will have additional column, score, which is the average score in reading and math tests. Then let's say I want to see what is a correlation between income and score. So if I do like this, guys, it's a command, right? Correlation. If I just write income and score, what do you think? Will R be able to give me the result?
No.
There's going to be an error. It doesn't know what file to take it from.
That's exactly right. Why is the error? Because R does not know where is this income, where is this score, where are those variables? And R is confused. But when I write like this, instead of that, if I write, sorry, what did I do? Okay, instead of this, if I write correlation, and then I'm saying CA schools, and then $, and then it gives me the list of variables which is in the data set, right? I just choose which I want to choose, right? So whichever, so whatever, so which one? In this case, we had what? Do you remember? I forgot. What was it?
Income.
Income. Okay, let's do income. Where is income? Income here. Okay, then you need to do comma, and then again CA schools, and $, and whatever. Then you, let's say, income and English, whatever, reading school. Okay, let's see if there is a correlation between income and reading score. And then you select it, run it, and it tells you 0.69. But does it tell me anything about causal relationship? No, because this is just a correlation, right, between income and reading score. Guys, are you with me?
Yeah.
Now, if you want to see what's the causal relationship, then you have to run a linear model that is estimated using OLS, and which is on this line number 30. In my case, it is 32, but we modified, right? I'm talking about this line. Do you see it?
Mm-hmm. Yes.
So what I have here is the following. So this is a name that I gave to the model, linear model equals, and this LM stands for a linear model. And score is our dependent variable, income is our independent variable, and I am taking these variables from data equals, which is CA schools. Okay, and if you select it and if you run it, you will obtain results which you don't see, but then you write linear model and then you run it,
Spelled linear wrong. Professor, I have a question.
Yeah.
So the variable size and score, would you be able to call it if it's not on the very end of the column or axis?
Sorry, can you please repeat?
So if you go to line 23 and 24, you see student and teachers.
Uh-huh.
So those variables, what if student was in the middle of the data set? You wouldn't be able to call it, right? It has to be on the very end.
No, it doesn't matter because, I mean, students, this is a variable in this data set, no matter where is it in the beginning, in the middle, or in the last column, doesn't really matter. Simply, it should be there.
Okay. So what I'm asking is that, so if one of the, if you go to the data table, could you do that real quick?
Mhm.
So you see how it's on the very top of the thing, the top of the data? So if that was in the middle, it wouldn't be able to call it, right?
No, because students, that's the name of the variable, and then you have the values for
Oh,
every
then that would be the
observation.
value, yeah. Okay.
Yeah. So I wanted to so guys, did you understand what I did here? You just run a linear model using this column.
Was score the X or the Y?
Sorry. Score is our Y.
Thank you.
Dependent. Income is the independent. But let's say I want to run it on class size. Size is what? Size is our STR, right? I run it, and then a linear model, and then you got these numbers. Minus 2.28, do you see? Guys.
Yes, we see.
And also 698.93. 698.93, that's the intercept, minus 2.28, that's the slope estimate. And then if you go to the Excel outcomes that you guys already have, where is it? Do you remember? I think it was, where was it?
It's right there. It's coefficients on the left, line 16.
Yeah, but was this or it was something else? I think I have a few of these here.
Sheet
But
10.
It was 10? Good, thank you very much. But you have the same numbers, right?
Professor, what does the tilde key mean on R?
Let me see.
Oh, class is over.
Class is over. The class is over. Guys, what did you ask?
What is the tilde key? So on line 32, between score and size, there's a tilde key. On 32, line 32, there's the key between score and size. What does that mean?
It means that you are regressing. That's like I am telling, this is like I'm telling R that is the dependent variable, and whatever I write after is the independent. I can also write whatever. I can also write size, and also I can write plus. It's not really plus, but it's like.
Also do it for this one and that one.
Yeah.
That one.
True, but right now we have just one independent variable, which is size. So this icon, this sign tells R that that's the dependent, that's the independent variable, and just I want to regress the dependent variable on the independent variable. But then you need to let R know where these now variables are, and this is where you tell R that variables are in data, which is in data, which equals to CA schools.
So we run the formula first, and then we run the linear model, like when we write it out, right?
Yes. So
okay.
you have the data set, and then you run this comment.
Okay, cool.
And as I said, you can of course change these dependent, independent variables as you like, but this is how really do. How you run a linear model in R, but we will. So this model has certain issues. I already said certain values, numbers are incorrect. We have to correct for that. And that's the topic of next class or even the next few classes. So today's class is over, guys. You can take a look at what comes after in this R code, but as I said, we will do this step by step over time, so you don't have to worry about anything.
Professor, the next class is on Wednesday of next week, right?
Next class is Wednesday because Monday is a holiday, I think.
Okay. Yeah, thanks.
No
Thank you
problem.
for the class.
No
Do
worries.
we have to save this?
They took it?
You don't have to save it, but
It's already saved.
To school or what?
you have the code, guys. So you can always obtain this result whenever you want.